Now let's see the questions related to chapter 21, experimental design and separation technique. From these chapters, chapter 21 and 22, at least one question will appear in the exam. And mostly from chapter 21, the questions related to chromatography comes in the exam. So we will mainly focus on such questions. But before going to that, we will check now what are the apparatus that are used, because sometimes the questions come in the exam related to the apparatus. See this question: which piece of apparatus can only measure a single fixed volume? So you don't have to look for the options, just look at the fixed volume word. If you see a fixed volume word in your question, then it means it's the only option will be the pipette. Okay, which option is the right option? The pipette can measure the fixed volume. The other one, the beaker, burette, they can measure different volumes, but the fixed volume can be measured by the volumetric pipette. So option D is the right option. Now let's see another question. The concentration of acid and alkalis can be determined by titration. So all those students who are working in the labs and who have 2 years of IGCSE course, they already know that which apparatus is used for titration, that is 2 and 4, because in the one we usually use the burette, and we have, because it can control we can also control the measurements, right? So this option can be the right option. And thermometer, of course, it's not right, because we are not checking the temperature. We are actually mixing the acid and alkaline solutions to neutralize them, okay, to get our product in a form of salt. So 2 and 4 option is the right option. So that is option D. Let's see this question. Very important question, and from last 2 years, mostly the question related to chromatography comes in the exam. So to answer such question, you have to first look at this picture. Okay, this is the picture of the chromatogram, the paper on which chromatography is done. So now let's see, there are two main things, baseline and the solvent front. Okay, so whenever in exam they ask you for some calculations, you always have to calculate the measurements between the baseline and solvent front, and you have to ignore everything at the top or at the bottom of this solvent front and baseline. Okay, so now let's see one by one each statement. Which statement is correct? Q is a pure substance. Okay, what chromatography is used for? Chromatography is used to separate the mixture present in a compound, okay, or the mixture of the elements. Actually not a compound, but the mixture of elements you can separate easily through chromatography. And what is the principle behind it? Is actually the solubility. According to their solubility in a particular solvent, you can separate them, right? So if you see over here, Q is a pure substance, that option is why not right? It's wrong, because if you see, we can see two spots over here. X was our Q, right? The substance Q. Now it is giving you two spots. It means it is a mixture of at least two elements. So it is not a pure substance. A pure substance is not a mixture, right? It is only made up of one element. So that's why this option is wrong. The RF value of the lower spot is 0.25. It is, no measurements are given over here, so we cannot conclude that it is 0.25 or it is more. Okay, so that's why option B is also not right. Q is a mixture of at least two different substances. Yes, this option is right. Why? Because we can see two spots over here, so at least it is made up of two elements, right? Third, Q is a compound of two elements. Again wrong, because in chromatography we usually separate the mixture, not the compounds. You cannot separate the compounds just through chromatography. Okay, so option D is a wrong option. So option C is the only right option over here. Now let's see the chromatogram of the substance as is shown over here. Some distance are labeled in the diagram. How is the RF value of substance as is calculated? Okay, to measure the value of RF, you have to memorize the formula, that is the distance traveled by the substance. Okay, the substance you are measuring, or you can say the unknown substance, divided by the distance traveled by the solvent. I think it's an easy formula. Okay, so the main mistake usually students do in the calculation is that they don't know from where the measurements they have to take. So I already have told you that you have to measure everything between the baseline and solvent front and ignore every other calculation or any other measurement. Okay, so the measurements that are below the baseline, you have to just ignore them, and the measurements that are above the solvent front, you have to ignore these measurements and also these measurements. Okay, so now let's see. First measurement should be from the baseline up till the substance has moved, right? So this is y divided by, okay, so here this option can be right, C or D. Now let's see the solvent, how much solvent has moved. So again, the solvent we have to measure from the baseline. Can you see this line? Yes, so this is the baseline and up till the solvent front. So it means X is the right answer. So Y over X is the right answer to calculate the RF value for the substance S. Okay, C is the correct option. Now let's see another example of this one. And this is how you have to measure the calculation. Again, I am repeating, you must know the formula. RF value is equal to distance traveled by the substance, okay, which we are measuring, divided by the distance traveled by the solvent, okay. And these distance you have to measure between the baseline and the solvent front. Now let's see what is the RF value of Q. So the distance traveled by Q is up till here, right? Can you see here? Yes. But the starting point should be the baseline, not from the Q, from here, right? From the base. So your starting point is the baseline. So how you can measure 83 minus 13? 70. So 70 is the first calculation you have to do. That is the distance traveled by your substance Q. Okay, now 70 divided by what? 70 divided by the distance traveled by the solvent. Let's see where our solvent has traveled. So you have to measure up till the solvent front from the baseline. Again, if you check, we are not given from baseline to solvent front. The measurement is from the bottom, right? So you have to minus this 13 from here. 114 minus 13, what is the answer? 101. So 70 divided by 101 is the actual calculations you have to do. So 70 divided by 101 is 0.69693. Okay, so the correct option here is C. So the RF value for the Q is 0.69. So I am repeating again that you have to measure all the calculation between baseline and solvent front. If you will not measure, then you will get the wrong answer. Okay, just ignore everything that is below the baseline and just at the top of the solvent front. So you have to remove just ignore these calculations. You have to measure anything that is between solvent front and baseline. Okay, so option C is the right option. Let's see another question. RF value are used to identify unknown substances using proper chromatography, and which statements about RF values are correct? First, RF values are always less than 1. Yes, that is the right option. All the values are always between 0 and 1. Okay, so if your answer RF value is more than 1, it means you have done some mistakes in your calculation. Second, the formula of RF value is the distance traveled by unknown substance. But can you see here they have written solvent, so it is wrong. Okay, the higher the RF value, the further the unknown substance travel. Yes, that's right. Higher the value, the more it will travel, because RF value actually tells you the solubility of the substance. So if the substance solubility is more in that solvent, it will travel more. Okay, so the RF value will increase. So that's why option 3 is right. Let's see option 4. RF value is not affected by the solubility. That is wrong, because the chromatography main principle is based on solubility. Okay, so of course the RF value will be affected by the solubility, because the RF value is actually the distance travel, and the distance is actually depending on what? On the solubility. So this option is also not right. So which options are right? 1 and 3. That is the option B. So option B is the correct option.